Alright, in this video I'll be going over the test 3 review. So on number 1 it says find any restricted values for each function, then determine the domain. And I should say that you should be able to write that domain in interval notation. So on the first problem here, you got to figure out what x value, if you plug it in as an input into this function, will cause your denominator to be 0. Well, the easiest way to find it is to actually set your denominator equal to 0. And so we'll add 4 to both sides. Divide by 3, we get 4/3. And so that's the value that x cannot be. 3 times 4/3 would actually be 4, and 4 minus 4 would give you 0. And so our domain is every other number, negative infinity to 4/3, union 4/3 to infinity, which is basically all real numbers except 4/3. Now on this one, I think I would factor this as x minus 7 times x plus 7. Notice the denominator there is a difference of squares, and so you can see that x can't be 7 or negative 7. So our domain is everything else, negative infinity. Now be careful here, with interval notation you always go from left to right, starting at negative infinity, so we'll go to negative 7, and then we'll go from negative 7 to 7, and then from 7 to infinity. So again, this is just the set of all real numbers, but we're excluding negative 7 and 7. Now here you're going to have to use the AC method, and this is the easier type to factor because that's a 1. We know we're going to have x here and here, and we need two numbers that multiply to negative 16 that add to negative 6. 2 and 8 are the numbers that are going to work, and since they multiply to a negative 16 and add to a negative 6, I want the bigger number to be negative. So you can see that x can't be negative 2 or 8. So our domain goes from negative infinity to negative 2, and then from negative 2 to 8, and then from 8 to infinity. In fact, if you showed the number line, you would have a hole at negative 2 and at 8, and your domain would be everything else. So notice this interval here, that's this interval here, that's here, and this interval here is here. Alright, let's move on to simplifying fractions. Now, you ought to know the process, and we talked about how you simplify rational expressions by canceling common factors. Well, that indicates that first you need to factor these. Notice for this first one, we can write this as 8 over 8 times x plus 2. We can factor the denominator here. And if we divide by 8 in the numerator and denominator, we get 1 over x plus 2. Here I have a difference of squares in the numerator that factors as x minus 5 times x plus 5. In the denominator, again, I've got a 1x squared here. This is a trinomial, so we're going to use the AC method. We know x times x will give us the x squared. In these two spots, we need two numbers that multiply to negative 30 that add up to 1. So you should be able to figure out the numbers at work. You can look at all the different factors of 30, but 5 times 6 is the one that's going to work. And we need opposite signs since they multiply to a negative 30. And since they add to a positive 1, we'll make the bigger numbers positive. So notice negative 5 and 6 are the numbers that work. So this will be minus 5 and x plus 6. So these guys cancel. You're left with x plus 5, so we don't really need the parentheses here. So x plus 5 over x plus 6. Now you might be tempted to do more than what we've already done, but you can't cancel these x's because they're terms. Notice there's 2 terms in the numerator and 2 in the denominator. And one of the things that we've learned is we can only cancel factors, numbers that are multiplied. Notice x minus 5 was multiplied times x plus 5. And so that's why we were able to cancel that. We cannot cancel a term or part of a term. Alright, so I would encourage you to try number 4 if you haven't already. Alright, so if you look in the numerator, remember the first rule of factoring is to factor out a GCF, or at least to look for one, and notice 4x is the GCF there. It'll be 4x times x minus 5. Notice when I multiply, I get where I started. In the denominator, we've got another trinomial to factor. It'll be x and x, and I need 2 numbers that multiply to negative 5 and add to negative 4. Well, 5 only has 2 factors, 1 and 5. They need to be opposite since they multiply to negative 5, and they need to add to negative 4. So make the 5 negative, and that'll work. So we got a plus 1 and an x minus 5. Now, one of the things that's kind of nice is we're kind of expecting an x minus 5 factor, and that's what we got. If you had your signs the opposite here, if you made that mistake, you wouldn't have a common factor, so I'd at least be suspicious and I'd double check my work. So we do have a common factor here that we can cancel. We're left with 4x over x plus 1. Again, it might be tempting to cancel this term, but we can't cancel terms or part of a term, so we're done. All right, multiplication is actually quite similar to what we just did above. The only difference is we're going to factor and cancel any common factors. Oh, excuse me. And the last thing we're going to do is multiply across, because that's how you multiply fractions. So we could start by multiplying across and then canceling our common factors, but it makes our work easier if we do the canceling first. So do we have anything we can factor here? Well, I've got an x minus 2 times x plus 2. This is a difference of squares, so I can factor that. But other than that, I'm just going to write 12 times x here. It'll make it a little bit easier. In the numerator, we have 3x over x plus 2. Now when I cancel, I like to put parentheses around what I have. So I'm going to cancel the x plus 2's. It's always something in the numerator with something in the denominator. Notice the x's here also cancel. And in fact, how about the 3 and the 12? You can divide by 3, you get 1. Divide 12 by 3, you get 4. So now be careful when you multiply across. You've got x minus 2 times a bunch of 1's. So that's x minus 2. And in the denominator, you have 4 times x times 1, so 4x. And that is simplified. Notice we can't cancel the 2 with the 4 or the x's here because we have terms up here and cannot cancel a term. All right, if you haven't already tried number 6, I would encourage you to do that. Now, on number 6, we got a lot of factoring to do. So first of all, this is a trinomial, and hopefully you're getting pretty good at factoring those. It's a 1x squared, so this is the easier type to factor. I need 2 numbers that multiply to 12 that add to negative 7. And 3 and 4 are the numbers that are going to work here. Notice the signs have to be the same since they multiply to 12. and they're either both positive or both negative. Well, since they add up to a negative, they must both be negative. And notice that's going to work. Negative 3 times negative 4 is 12, and negative 3 plus negative 4 is negative 7. So it'll be minus 3 and minus 4. In the denominator, we have, now be careful, this is not a difference of squares because of this x. What I can do is factor out an x, and it'd be x times x minus 4. So notice we are not factoring a difference of squares there, we're just factoring out a GCF of x. Over here I'm going to write x times x, and this is a difference of squares in the bottom here. This will be x minus 3 times x plus 3. So before we multiply across, let's cancel common factors that are in the numerator and denominator. We can cancel these x minus 3's and these x minus 4's. And notice this 1x will cancel one of the x's here. And so as we multiply across, you can see we're left with x in the numerator and x plus 3 in the denominator. All right, let's move on to page 2. Now, the problems we're about to do on 7 and 8 here are really going to be very similar to what we just did. Remember, with division, we multiply by the reciprocal, or some people think of keep, change, flip, not KFC, but KCF. So we're going to rewrite the first fraction. We're going to keep that the same. We're going to change division to multiplication, and we're going to flip the second fraction. Again, we call this multiplying by the reciprocal. Dividing by a fraction is the same as multiplying by its reciprocal. And so now we changed it to a multiplication problem, and we'll do it just like we did the multiplication problems. We're going to factor everything that we can. Notice we got a bunch of, well, we got two differences of squares here. 3a times 3a gives us 9a squared. And 1's a perfect square. It'll be 1 and 1, 1 minus 1 plus. We know that a squared minus 9 could be written as a minus 3 times a plus 3. So let's go ahead and rewrite this part. That's all factored. So again, I'm going to put parentheses around anything that any binomials that I cancel. Let's see, I've got an a plus 3 here and here, and a 3a plus 1 and a 3a plus 1 here. So I'm going to be left with 3a minus 1 over a minus 3. Now again, you might be tempted to cancel something here, but you've got two terms in the numerator and two terms in the denominator. There's no factoring that we can do, so we can't do any kind of simplifying there. All right, now I'm going to write this a little bit over to the left here because we're going to have to factor a trinomial using the AC method the long way. So I want to leave some space for that. So again, you ought to be multiplying by the reciprocal. Now, I'm kind of taking this step by step, but you could be factoring this. You just got to be careful that you do keep the first fraction, change division to multiplication, and flip the second fraction. If you can factor that at the same time, that's fine. You just want to be careful about that. All right, so in the numerator here, we're going to get a minus 3 times a plus 3. We have a difference of squares. Notice in the denominator we have a GCF of 2a. 2a times a gives me the 2a squared. And I'm going to need a minus 3 here. 2a times a minus 3 gives me the minus 6a. Over here I have another difference of squares. 4a squared is 2a times 2a. Of course, 1 times itself is 1, 1 minus and 1 plus. Alright, so let's see, we need to factor this trinomial, 2a squared plus 5a minus 3. We're going to use the AC method, and we don't really have a shortcut here because it's not a 1a squared. So in this case, AC is 2 times negative 3, or negative 6, and our b term is 5. So I need two numbers that multiply to negative 6 that add to 5. Now your only options are 1 and 6 or 2 and 3, but they need to have opposite signs since they multiply to a negative, and they need to add to a positive, so keep your bigger numbers positive and your smaller ones negative. Notice negative 1 plus 6 is going to give you the 5 you need, and of course negative 1 times 6 is negative 6. And so we'll split our b term, we'll get 2a squared minus a plus 6a minus 3. So I'm using the negative 1 here to go with this a, and a 6 to go with this one here. Notice 5a does equal a negative 1a and 6a. And now we can factor by grouping. We can factor out an a here. It'll be 2a minus 1 times a, or a times the quantity 2a minus 1. So when we factor out the GCF here, we're expecting to get a 2a minus 1, because these parentheses should match. And notice, to get the 6a here, I need to multiply by 3. So we'll put a plus 3 here. 3 times 2a gives us 6a, and 3 times negative 1 does give us the minus 3. So finally we have two terms with the common factor of 2a minus 1, and the other factor is a plus 3. And so finally I can put those in. I'm going to go ahead and just put this in a little box over here. We just factored this trinomial here. We got 2a minus 1 times a plus 3. So there's a lot of stuff that factors or cancels here. We got the a minus 3's here, we got an a plus 3, and we've got a couple of 2a minus 1's. So we end up with 2a plus 1 over 2a. Looks like that's all that's left. And I just want to point out, you actually could write this as 2a over 2a plus 1 over 2a, which would give you 1 plus 1 over 2a. But honestly, this is perfectly fine the way it is here. But again, if you said 1 plus 1 over 2a, that would not be wrong. But again, there's really no reason to go any further. There's nothing here that factors in the numerator or denominator. Can't cancel the 2a with this 2a because this is a term, so we're done. Alright, I think I'm going to go ahead and stop here, and we'll pick things up with addition and subtraction next.